Hello, I hope you're doing well. Welcome to this project tutorial where we are going to make a very simple water detection circuit using the Arduino microcontroller. Now, you may have a similar problem as me, or you may not, but my basement can get a little wet. In fact, it can flood, which is absolute misery if you've ever experienced such a thing. So what I'm trying to prototype, I'm in the process of prototyping, is a water detection alarm that's going to let me know if water gets above a certain level in my sump pump crock, because that would tell me that my sump pump has failed, in which case water damage is imminent. So what we're going to do in this tutorial is take two very simple circuits and we're going to combine them together to create a more complex circuit but still a very simple circuit. The application of this specific circuit that we're going to make is rather limited because, again, this is a proof of concept for me as I prototype. You'll find if you make the circuit that the alarm, the speaker, is actually very quiet. It's not loud enough to wake me from a sleep. And you'll also find that the wires that go into the water are, I'm just using really short wires, and that's not going to be practical for what I need to do. But that's not my goal right now. My goal right now is to prototype to see, well, is this even possible what I'm trying to do? Do I have the knowledge and understanding to make this thing? Just keep that in mind as we go through this. But regardless, it's still a fun project to do, and it's good to look at two separate circuits, figure out how to integrate them, and figure out how to integrate the code together. So that's what we're going to do. So let's go ahead and take a look at what we need. For this tutorial, you're going to need an Arduino board. I'm using the Arduino Uno, but any Arduino will work. You'll need about 7 jumper wires. If you get 2 that are longer, it's going to work out better for the water probes. You're going to need an 8 ohm speaker. You can find these just about anywhere. And you're also going to need 2 resistors. One needs to be 100 ohm, and one needs to be 10k ohm. That's 10,000 ohms. And then you'll also need a breadboard. And then finally, you're going to need some type of water source like an oasis in a desert. But if you don't have that, a small cup of water from like the Appalachian Mountains or maybe from water from Nepal, something like that, that should work fine. All right, so let's first talk about the water detection circuit. So here you can see the breadboard layout. Now let's go back and let me reiterate that I am prototyping a circuit. So when I prototype, I'm trying to get to the quickest solution. What I usually do is I look for existing circuits that I can use. It just so happens that a push button circuit is a perfect water detector. All I have to do is take out the push button and leave the 2 open lines that would normally be on either side of the push button open. And it's those lines that I place in the water. And when they're placed in the water, the conductivity of the water completes the circuit. So it would be like pressing the button. So all I have here is a wire going from pin 2, a hookup wire going from digital pin 2 on the Arduino to the breadboard. And then I hold that pin low using a 10k resistor. So I'm taking that to ground. And you can see I've got the breadboard connected to ground. And then from that digital pin 2, I also have a wire going out, and that's going to be one of the probes, quote-unquote probes, that go into the water. The other probe is simply going to be a 5-volt line. So I'm just running a hookup wire from the 5-volt line, and that is all it is. That's all this water detection circuit is. So now let's take a quick look at the code that runs this circuit. So here we are in the Arduino IDE, and I want to reiterate that we are in the process of prototyping. And so what I'm trying to do is get to the quickest solution I possibly can. I want to get something working as fast as possible. So what I'm going to use, we already used that pre-existing circuit for the button. Well, I'm going to go ahead and use a pre-existing sketch for the code. So I'm going to go to File, Examples, Digital Button. So this is all code that's pre-installed on your Arduino IDE. I'm not going to get too in-depth on this code. If you should be able to follow along if you've gone through the Arduino course for absolute beginners. There's a free version on YouTube. So if you're watching me go through this code and you're kind of totally lost, definitely check out that course. It kind of help explain some of the stuff that I'm moving over a little more quickly. But so let's go ahead and jump into this sketch. So at the top we've got some comments. We know that our circuit's going to be a little bit different, but really not too much. Simply we just don't have that push button attached. We can thank Dojo Dave and Tom for making and modifying the sketch. And of course you can go to the Arduino website and check out the tutorial on a button if you wanted to. All right, so at the top, we are declaring some variables. They've got constants. They've got one for their button pin and one for their LED pin. Now, this circuit uses an LED, so when you would press the button, it would turn an LED on. Well, I want to use the LED still. I'm going to use the LED that's already integrated into the Arduino board, so I'm not going to use an external LED. But I still want that LED to come on, but now instead of a button press, I want it to be when I put the detectors, the two water probes into the water. So those work fine. In fact, I'm not even going to change the name. I'm just going to keep button pin the same, just again because I'm trying to get to a prototype as quickly as possible. And button state is the variable that is going to track whether the pin is, or whether the button is being pressed or not pressed. In our case, that will be whether the probes are touching water or not touching water. So we come to the setup. They are setting the mode of the pins. So one pin is an input and one pin is an output. So the LED is going to be an output, and the button pin, that's going to be digital pin 2, is an input. And then down in the loop, what they do is the first step is they sample the state of the button. So they do a digital read of button pin. So recall, button pin is just digital pin 2. So button pin is a variable and it's the number 2. So digital read is going to look at pin 2 and it's going to say, hey, is the pin high or is it low? Now, if the pin's low, that means it's not touching any water. That means it's grounded out through that 10K resistor. If the pin is high, that must mean there's water present, because now the 5 volts can travel across the water to the other pin, to digital pin 2, and finish that connection. So at the bottom, and this is kind of the algorithm that the loop uses, is an if-else statement. It says if the button state is high, do a digital write and turn the LED on. So turn it high. So it's going to apply 5 volts, high voltage, to pin 13. Otherwise, it says else, do a digital write and turn the pin off. And that's it. And then through the loop, it jumps back to the top of the loop and it checks again. And it just keeps checking over and over and over again. So that's pretty much the code, pretty simple. So let's go ahead and take a look at the code in action. So I've got my Arduino circuit set up. I've got a spring holding the wires together for the probes. And all I'm doing is dipping it in and out of water. And you can see if you look at the LED on the circuit, it's blinking on and off. So when the probes are in, the circuit's been completed, the LED comes on. Otherwise, else, it's off. So that's pretty simple. All right, well now let's check out the speaker circuit. So here is a very simple speaker circuit. All I've got is a 100 ohm resistor going from digital pin 8, and I've connected it to the positive terminal of the 8 ohm speaker. Now, the terminals on speakers, usually they're just like little metal copper loops. And having an alligator clip would help if you don't want to solder, if you don't want to make this permanent. And then all I've taken is a jumper wire from the negative terminal and I've connected that to ground. And that's it, that's all it takes. So now let's take a look at the code we're going to use to try to get some noise out of this speaker. For the output on the speaker, I went to the Arduino reference to look for something that might work. And if you come down on the right side where the functions are listed and you go to Advanced I/O, which is Advanced Input Output, and click on the tone function, there's a handy function that already helps you make little beeps with a speaker, just like the one we're using. It's really pretty simple. So here's the syntax down here. And so here's the function, it's called tone. And there's 2 ways you can use it. You can specify the pin, so for us it's going to be pin 8, and then you specify the frequency, and that basically adjusts the pitch or how the tone is going to sound. Or you can use an expanded version and you can pass the pin number, so again pin 8, the frequency, and then the duration you want the little beep noise to be. So I'm going to use this version of the tone function, and what I did, so let's go to the Arduino IDE. What I did is I went looking around the Arduino website, which I often do because they've got a lot of great resources on the website, and I found a tutorial for the Tone 2 and I highly modified it to kind of fit what I wanted to do. So here we are at the top of the sketch. We've got some very simple comments. We can thank Tom and Michael Flynn for originally creating this tutorial, and you can check out the tutorial on the Arduino website there. All right, so this is how basic this is. In setup, I am simply setting the mode of pin 8 as an output. And again, that's where I have the one side of the speaker attached. And then I'm using the tone function in the loop. So I'm specifying digital pin 8. I want the frequency to be 2000, and that's in hertz, so 2000 cycles per second. And then I want the duration to be 1000, and that's in milliseconds. So I want this to beep for 1 second. And then I have a delay of 2000 milliseconds. That's 2 seconds. So why a delay of 2000? So when tone is called, it doesn't delay the program until the finish of its beep. So again, this is a second long beep, 1000 milliseconds. So we're going to go through the loop. It's going to call tone. It's going to start playing this beep. And if we didn't have this delay, then we would immediately go back up to the loop, and then tone would call that. Tone would basically be reset. So it would reset the tone again. It wouldn't wait for that 1000 seconds to go. So in order to get like a beeping noise, like so we can hear it on and off, we need to have a delay in here that's longer than the pulse. So what's going to happen is we're going to hear this tone for 1000 seconds. It immediately is going to jump to this delay. So the first 1000 milliseconds of this delay is going to be tone beeping. The second 1000 milliseconds is going to be just nice, quiet. I don't get much quiet in my house, so that's great. And then we go back into the loop. Tone is called again. It's going to start beeping for 1000 milliseconds. We're immediately delaying. Again, the first half of that delay is the beep. The second half is the quiet, and then over and over and over again. And that's basically how we do it. So I just tried to pick the most annoying beep noise I could, and that ended up being about 2000 hertz for this example. All right, so let's go ahead and see it in action. Pretty annoying, huh? I think I picked a good annoying noise. And that's pretty much it. It's not very loud, but like we talked about, this is a prototype for me. So at some point I will have to amplify this audio in order to get something that's really going to get me out of bed in case I do have water starting to spill into my basement. But that's not what I'm going to do right now. Again, I'm just going to move forward with now integrating this alarm noise with the water detector. So let's go ahead and take a look at how we're going to do that in the circuit. So you can see here in the combined circuit diagram, or the breadboard diagram rather, that all I've done is pretty much tacked the two together. And I'm using a common ground. That is, the ground between the water detector circuit and the ground between the speaker are the same. So I just have one wire going from ground to the breadboard, ground on Arduino to the breadboard. And then I have the negative terminal of the speaker connected to that ground. And I also have the 10K resistor for the push button connected to that ground. So both of those circuits share the same ground, which is perfectly fine. Otherwise, not much has changed here, so this shouldn't be too hard to do. All right, well, let's see what we have to do to the code to make these both work in unison. Okay, so far we've combined the circuits, those two simple circuits, and that was really easy. And you know it's going to be just as easy to combine this code. So here I am in that speaker tone example, and you'll be able to download this sketch here from the website. The link will be in the description below. So all I'm going to do is I'm going to come down to void loop, and I am simply going to copy this code that was in the loop. Again, it's the tone function and the delay. So I'm going to copy that, and then what I'm going to do is go to File, Examples, Digital, and I'm going to go back to that button example. I'm going to open this up, and then I'm going to come down, and now what I want to happen in the loop when it says if button state is high, so this is when we are testing, or this is when we're saying, hey, you know, we tested that button state. If indeed it is high, if that condition is met, we want to turn the LED on, you know, turn it high, 5 volts. Well, now what we also want to do is, let me just paste this in here. Now we want the tone to go off. So it's going to turn that LED at pin 13 high. It's going to start the tone, and then it's going to delay so we can hear a beeping noise. And it's going to continue to do that every time it goes through the loop if that probe is still, you know, if the probes are still in the water. So that's pretty much all we have to do to make this work. Now else, the else statement simply turns the LED off if there is no water, and we don't need to turn that tone off because if you're not calling the tone statement, then it's not going to play a noise. So that's really it. All right, well, let's go ahead and upload this, and then let's check out and see if the circuit works. All right, so I've got it set up, and I'm just going to go ahead and put the sensor in the water, and let's hear for the... So you can hear it beeping now, And notice the LED also comes on. And I can pull it out and it stops. I can drop it back in and I can pull it out. Okay, so you can see where this prototype is already working. It didn't take us but a couple minutes to get a working prototype of a water alarm circuit set up on the Arduino. So hey, I hope this was helpful, and maybe in some later tutorials we'll work on amplifying that noise so we can hear it. And I think I'm also going to work towards building an Ethernet version where it will tweet me or alert me in some fashion that that water's gotten into my basement. So I hope that was helpful. I hope you have a great day. Bye.